Hello everyone, Alvaro here in the editing room. Just want to apologize, I recorded with my webcam microphone once again. I try to clean it up a bit, but yeah. Either way, Jen and Hash do most of the talking, so I think you're really going to enjoy it. Hello and welcome to the Unnamed Reverse Engineering Podcast. I am your host, Alvaro, and with me here is Jen.
Still Jen. We're still not good at intros.
Nope.
But we'll get it right one day.
Maybe we'll actually write a script.
And with us today, we have a very special guest. Hash, tell us about yourself. Who are you? Hi. What do you do?
So I'm Hash. I'm a reverse engineer based in Dallas, Texas. I'm pretty well known for smart meter hacking, but I've kind of done some other stuff in the past, like reverse engineering the Lidar on the Lidar vacuum cleaner and some other random things like that.
Welcome.
Cool.
You recently gave a talk at Remoticon at the Hackaday, I guess SuperCon remote version about the smart meter hacking. I think that's I guess I'd seen some of your work before, like in the news or on YouTube. But I guess most recently that's where we saw you, and we were really excited to have a chance to chat.
Yeah,
I appreciate that.
Yeah, I think the thing for our audience to know is that if you really want to be on the show, you can DM us. Or you could just be presenting at a Remoticon and we'll probably see.
I got a Twitter DM. That was awesome. Just like, hey, you want to be on the show? I was like, oh, that's super cool.
It was really good. There was just not enough time in that session to go through everything. Tell us a little bit how you got started in reverse engineering.
Yeah, so I mean, I've always been interested in how things worked ever since I was a kid. And it kind of, I take anything apart, when I was probably 3 or 4 years old enough to hold a screwdriver. I went in the garage. I got one. I had my little toy. I saw my dad in the garage working on his car. I grabbed that little toy and tried to put the screwdriver in it, but I was holding the toy up and kind of pointing the screwdriver towards my face as I was trying to put it in. And as it slipped, it hit me in the eyeball, one of my eyes on the side. And, freaked my mom out, had to take me to the hospital, and luckily everything's fine. But I mean, since I could hold a screwdriver, I've been trying to take things apart. And ever since then, it was always a lot of it, mechanical pieces were interesting, but I was always interested in electronics. My parents didn't know anything about electronics, and radio controlled cars, every holiday, anything I could ever get a radio controlled car. I probably had 30 or 40 of them growing up. And so I take them apart and wonder, like, how does this thing work? And what are all these little parts? And go to Radio Shack and when there was Radio Shack and it actually sold parts, and look at all those things and try to buy them and build circuits. And I think a lot of it was fueled from movies and things like that as well. Back to the Future and Short Circuit and all these kinds of different movies and TV shows were very electronic, techie oriented, it seemed at the time, at least the things I liked.
Yeah.
And so, that's a lot of what got me into it, was just trying to understand that stuff and then wanting to make that stuff myself. And so there was no internet, I'm 42 at this point. So when I was a kid, it was like you went to the library and there was 6 books on electronics, and I checked out all 6 of those books repeatedly and tried to teach myself electronics from books at the library or whatever you could find, right? Nobody knew anything about that I knew in this small town in California that I was in at the time. So it was just a passion to try to learn and understand.
So it sounds safe to say you were not growing up in Silicon Valley then, because
no, I was near, I guess, Silicon Valley. I was in Modesto, California.
Oh,
which has nothing to do with electronics whatsoever.
No, but people regularly commute from there now.
Absolutely.
To Silicon Valley.
Yeah, but that wasn't anything that anyone I knew was doing.
Yeah.
And so, it was just, it was really a desire to learn and to be able to make these things myself.
So I have to ask then, how effective was it to check out the books from the library versus going to Radio Shack and maybe buying one of those like experimental kits?
Yeah, so I had some of those. I had all the little Forest Mims, I think the third
Mm-hmm.
Yeah.
electronics, like little different things about 555 timers and all that
Yep.
stuff. A lot of it was, try to first teach yourself schematics and what are these things and how to read them after looking at all these parts. I used to had a little junky soldering iron and I didn't have much money. So I would just, everything I took apart, I just scavenge parts, right? So I'm desoldering I still have up in that cabinet behind me a little bin that's from when I was a kid that has all my resistors and capacitors. Like I just can't throw that stuff away. It's like, it's like there's a lot of hours of effort to take that stuff out, right?
That's valuable right now, right?
It probably is. There's probably some good stuff in there. Yeah, and just supply chain wise,
Exactly.
but yeah, it was compared to how easy it is to find information now and things. It was a very different way to learn, but it definitely teaches you persistence for sure.
Oh yeah.
Yeah, so that's some incredible persistence there, especially because you didn't have a parent that was
No, yeah,
helping you there.
neither one knew about anything. At one point, I had a neighbor that used to have an electronics store,
Mm-hmm.
and the first computer I ever got, let me think, is that? Yeah, he had a Sinclair ZX81, which is a little touch membrane computer, and it was in the top of his garage. And I used to mow his lawn to try to get some Radio Shack money, and I was like, I want that computer, and I think he made me mow his lawn like 30 times
Wow.
to get that computer. And he gave it to me after a couple mowings. I was like, I'll mow the rest on credit, right? And then he also sold me. This guy was pretty smart. A black and white TV, a little one, but the TV was huge. It took like 9D batteries, massive box, but a tiny little screen on the front of it. And so the Sinclair ZX81, trying to teach myself assembly from a book to that screen. It was like, you look back and it's like no one, I don't know if anybody today would like sit around and try to fumble with that for weeks and weeks and weeks to teach yourself assembly, right?
Yeah.
But yeah, that was how I did it.
That was my first computer too.
Oh yeah.
The first one I programmed on, yeah. And it was painful. I think I told Alvaro this when we were cleaning out my dad's place as he was downsizing. We found it. It was all in a nice container, and we had to toss it. Like that's a little. We also tossed a bunch of Commodore 64s. Don't tell people.
Oh God.
We kept the Amiga though.
Yeah, mine. I think I destroyed at some point because I took it apart. My desire was further ahead than my skill set, and so I took it apart. And I didn't quite know. And, you couldn't just go online and Google and find data sheets for everything and what's the pinout. I had kind of the schematic, but I didn't really have any data sheets on these parts unless you were to write to a company and they'd mail you the data book or whatever. And I didn't even know that until later in life that was even an option. And I think I was trying to hook up LEDs to it. I wanted to make a Knight Rider light, go back and forth. And so I just, I wanted to make that so bad. That drove, I don't know how many years of learning and different things, hooking LEDs to parallel ports on computers and trying to program that, using BASIC and out, 888, 2 and whatever to turn. All that stuff drove trying to make that light all the way to learning about PIC microcontrollers and programming those. It was like, it's interesting, these little things that, hit you in childhood or whatever that drive learning for so long.
Wow.
Did you end up going to school for electronics, or were you just mostly self-taught and went with that?
Yeah, so I would say, I graduated high school. I went to college. I was going to get a degree in electronics engineering, which kind of foreshadows I was going to get a degree in electronics engineering. And so I went to school for a while, and it took me probably 10 or 15 years to figure out why I never got it, which I kind of did at one point, but I ended up dropping out because I got a job at this company. We had moved from Modesto to Fresno, and there was kind of two companies in that city you could work for if you were interested in electronics, and I worked at both of them. And so the first one I worked at was this small company. I got a job there. A buddy of mine just said, I was working in an arcade fixing video games, and he said, hey, there's this company, they posted an ad in the newspaper, which is how you got jobs in. They posted an ad in the newspaper, and they said, they're looking for some electronics people, and you have to know how to use an oscilloscope. And I thought, well, I don't have an oscilloscope. And so I quickly read and tried to figure out what is an oscilloscope and how would you use it. And I went and applied for this job, and I got the job at this company after talking to him and everything. And I was going to school at the time. And once I got the job at this company, they would let me use any piece of equipment in there. I mean, it was a free for all. Work as many hours as you want, right? And so I was kind of in heaven. And what I realized is, and so I ended up dropping out of school. I worked heavy at that job. I got another job in engineering department, the other company in town, and moved up throughout there and basically designed boards for them and programmed microcontrollers, all this stuff. And I realized when I was a kid, the thought, I guess at the time would have been put in my head is that you're going to school to learn how to do this thing. And the challenge was I'd spent so many years learning about electronics and all this stuff that as I got to school, it felt so slow and it was so far. And even when you were getting to the advanced classes, it felt so far from what I had done. And at that point, the internet had existed. The internet existed for a few years and I was on it. And at this point, I could find anything I wanted to learn and stay up all night long and learn about it. And so for me, I was like, I don't understand the value of this thing that I'm going to because it's not going to give me what I thought it was going to give me. I can already get that. And so, the value of the degree itself aside and, what it can help open doors to get jobs and things like that. I could not see
why
you
already
I
have
would
the
do
job,
this.
right?
You
had the
already
jobs.
opened the door.
I already knew how to do the thing. At one point, I did go back to school. One of the guys that was my engineering manager, he encouraged me, hey, you should go finish your degree. You're really sharp. These things, you should have it. Like, don't. So I went back and I was taking a digital logic class and it was such a breeze. And it just, and that kind of solidified it for me that I don't need this. And I also am not sure that engineering is the path I want to go.
Okay.
And I ended up moving over to sales engineering and then more of a sales kind of operations side of the businesses that I'm in. And I realized that I enjoy technical things. I enjoy reverse engineering, but I can make kind of my value at work is a little different and I can add more value in other areas with kind of using this analytical mindset. And so I ended up I was like, that's it. I'm not interested in the degree anymore and kind of moved on.
Well,
but for me, it was, I think what drove me was I feel like once you have an engineering degree, well, then you know everything. And it's like you realize, well, that's not the case. And it's just constant learning forever. And so I moved on from it.
Yeah. The other thing that I like about this is that there seems to be this, misconception that a lot of the reverse engineers, this is all they do, for work, for fun, that's kind of your life. And it's really nice to hear, counter examples. It's like, no. Like, you might be a fantastic reverse engineer, but for your day job, you do something completely different, separate. You still have tons of fun. It enables you to do all these other things, and you don't have to burn yourself out doing one thing like 24/7.
I would agree with you on that one too. Just there's two things. Like I feel like during that time period that you're mentioning, it was when you could still have somebody who did not have a degree, who was self-taught, who could still be hired and make fairly broad progress in their career without having the degree. And you're absolutely right. I met many people in my career or even at school that like they already knew how to program. They already knew electronics. They were there just for the paper, just because it was like a safety for them. But they could have easily, been designing boards and doing all that, because for a long time you didn't need to have a degree to do that. And now these days they won't even let you like look at a board or think about a board.
And I never learned how to make a circuit board.
Oh yeah, they don't teach you that at all.
Yeah.
They don't teach you any of that.
Yeah, a lot of people I saw that would go, and myself included, is you felt like you were going to get gated in your career. Like, I'm going to get to a certain point, and that's just going to hold me back. The same way a lot of times comes in MBA if you're on a management track moving up high, and it's like, okay, well, until you have that, like, you're gated your progress. And there was just something fundamental about me that disagreed with, something holding me back. And I said, okay, if I'm at a company where that's the case, then I'm at the wrong company. Because if the output and the outcome is less important than, the kind of the paper trail that somebody has, then that's just not a place for me. It's fine for that to be a place for other people. That's just not my place. Oh, yeah. And that's what I realized, like, if it's not working for me, I should move on to somewhere else.
I think a lot of people don't realize that until much, much later in their lives. Because, I have my MBA. I don't do anything with it. It just helps me talk to like cross-functional teams a lot more effectively.
Yeah, and I think there's value in studying, it's like
Oh yeah,
it's structured learning, and
yeah.
so and I think I've just had a challenge with structure. I like unstructured learning, unstructured challenges, and that's why I think there's a place for everybody.
Yeah.
I think a lot of people that have the structured piece, I can help them when they get to the unstructured challenges that
Hmm.
might be the piece that doesn't feel good. And I'm not looking to put all that structure in place and build the great presentation. I could just help refine it, And so that's why I think everybody's got their piece, that they fit in the puzzle.
Yeah, I feel like this is exactly why you got into reverse engineering. Reverse engineering is exactly like going against the grain, kind of deconstructing why is this like this? How does this work? How can I make it do what I want it to do? I think that's basically what your career has been, it sounds like.
Yeah, and also, there's a lot of decisions that are made along the way, and especially after you work in companies, you understand, why things are kind of done, and budget constraints and time constraints and all these things that drive decisions and parts availability, and
Yep.
and so you can kind of look at something with that mindset and say, okay, maybe why were these decisions made? How did these parts get on the board? And then what's needed from a manufacturing standpoint and testability standpoint. And, people laugh like, why would they leave the JTAG header or all these things? It's like, well, yeah, because you're trying to make 100,000 of them or 1,000,000 of them, and you got to flow them through, and every second you can shave off is good. And so there's all these things, and so that going in, like, here's the kind of limitations these guys have. They can't just hide everything.
Yep.
And the more you learn about even that, how products are made can help you with reverse engineering,
Mhm.
right? Outside of just
Yep.
the very technical things.
Absolutely.
Once again, stuff that they do not teach you in your undergrad or even your
Yeah.
graduate school about manufacturing anything. They
Yeah.
truly don't. Because what you'll find out is like, oh, the reason why that JTAG's still there is like they didn't want to remove it because of they need it for manufacturing. They didn't want to pay the extra step for the money to like basically put some glue over
Epoxy,
it to
yeah.
epoxy
Yeah.
exactly to
Yeah.
to obfuscate it.
Yeah.
So now that like everyone's fallen asleep in the audience, why don't we change change
I don't
modes?
know. People. We usually get feedback that people enjoy some of these like other things that are
Sidebars,
not.
yeah.
Yeah. So I'm a big fan.
Yeah, I'm a fan too, but like, at the same time, I don't know.
Yeah.
The people will comment regardless. So before we saw all your work that led up to Remoticon, um, you had this project around the XV11 Lidar and this reverse engineering project. Why don't you tell the audience about it?
Yeah, so I'd kind of always been interested in robotics. That goes back to like that Short Circuit movie, and there's a picture of Johnny Five up on my wall, and
Love that movie.
and yeah, and all that stuff, and so right before that, the Xbox had released that 3D sensor, whatever
Connect.
that thing was, the Connect, right?
Yes, I love
And
that
then
one
and
also.
then there was this challenge put out, like a bounty to reverse engineer that Connect. And I think it was like 10 grand or something. It was a pretty good amount of money.
Yeah, it was.
And because they wanted to use that device, more for open source projects and things, because it was a low cost sensor that had these really cool, 3D structured lighting. And so at the same time, the robotics community, there's this thing called ROS, the Robot Operating System, and a bunch of these other, sites that are kind of into robotics that sell servos and stuff said, Nito, this company, had released this robotic vacuum cleaner that, as opposed to like a Roomba or something that just drives around haphazardly all over the place and figures you'll cover the room eventually if you just aimlessly drive around in a kind of pattern. Nito had put a Lidar, which is, basically a laser sensor that scans around in a circle and makes a map of the room. And they would make a map of the room, and then they would intelligently drive around, kind of zigzag back and forth to cross the floor most efficiently. And so what that meant is that they could, put a higher power motor in it to vacuum better and use less battery power and all this. But that whole robot was like, I think, $400, including the laser scanner. Prior to that, the lowest cost laser scanners were $10,000, $7,000
Wow.
that would do a LiDAR scanner. So they basically drastically reduced the cost. There was an IEEE paper that the guys that I think had started that company or whatever wrote about this low cost LiDAR sensor. So the robotics community said, hey, if we could use this low cost LiDAR sensor in all of our other stuff, wow, that would really advance the state of all these things.
Yeah.
So they put out this bounty, and I think it came on Hackaday is probably how I heard it pop up. And and I'd work on all these different projects, but I saw that pop up and I thought like, maybe I could do that. Like it kind of speaks to what my strong points were: embedded devices and microcontrollers and these different things. And so, but it was $400, and I was when was this? This was quite a while ago. I had one young child and a good sized house payment. And so just dropping $400, was like, I'm like, hey, honey, like, I don't know. But
I got a vacuum
I bought it.
cleaner.
Yeah. But
And
I
it'll
bought it.
still work when I'm done.
Yeah, one would hope. So what I did was, this was over the Thanksgiving holiday.
Mhm.
I, like 10 years ago or whatever it was, I bought it off of Amazon because I was like, okay, I could return it if I need to, because I can take things apart very well, and you never know I was in there, right? And so that's a skill in itself. Sticker removal.
As long as there's no sticker on there.
Oh no,
Oh,
with the stickers on there, every single one was removed perfectly, all cataloged, so I could replace them on there. Perfect size screwdrivers, so you can't even tell the screw's been marred. To take the whole thing apart, strip it down, remove this Lidar sensor, and try to reverse engineer it. And so I basically worked on it 24 hours a day over the Thanksgiving vacation, because everyone around the world could work on this. And there was a number of people on these different forums trying to reverse engineer the protocol, figure out how it worked, everything. So I pulled it apart. I built this kind of jig so I could have it almost like on jack stands. If you think of a car, lift it up to so the wheels could spin. I put my robot.
How big is this thing? Like,
it's not that big, but it's like on my desk in my office, and it's kind of on jack stands. So its little wheels can turn, so it can think it's driving around. And I built a structured walled environment around it, so the laser sensor would always put out the same readings, so that I wasn't getting shifting readings trying to figure out what's going on, right? So I did that. I ended up working with a few different people that were writing some Python programs and things like that, and got the protocol figured out like in the middle of the night. And I'm putting a forum post up, and I'm recording some video late night trying to show like, I got it, 2:11 a.m. or whatever. Like, did I win the prize or not? And I woke up the next day to find out like, yeah, I indeed did win it. So it means I got $400 was the bounty. So it mean my robot was free. So I could keep, I didn't have to send it back to Amazon or whatever and try to put it back together. And so it was super fun. And then I just ended up doing like on Hackaday, you'll see more kind of reverse engineering on that, and went down this whole path of learning the robot operating system and trying to build simultaneous localization and mapping algorithms and stuff. Like, I don't know, just like a crazy rabbit hole that I went down because of this one thing, right? Like probably a year or more spent working on that stuff just because of that, that I just randomly kind of happened upon to be like, well, maybe I could win this bounty, right? Or win the thing. It was more about winning the challenge, right? $400, big deal for how much time you spend on it,
That's pretty cool.
Now, I have 2 follow-up questions. You mentioned that you're really good at removing the stickers, perfectly taking apart the screws so they don't look marred. Let's say I wanted to do this in my own spare time so I could return all these messed up products that I messed up back to Amazon without any questions asked.
Hypothetically speaking, of course.
Hypothetically speaking, because that's not who I am.
Well, I'll tell you where this is practically used, and it's a DEF CON at the Tampa Evident Village. They actually have contests to
Oh, I didn't even realize that was a thing.
Oh, yeah.
Well, sounds like you're competitive. So let's hear the hot tips here.
Yeah, I mean, I think a lot of it, it kind of came from, as a kid, they used to put stickers over screw holes and things, and that's how they would hide it or do the warranty thing. And so then it came down to like, what can you do? Can you heat it up? But most of the time it comes to just warming something up. Sometimes you get those stickers that when you peel them up, they just completely shred into pieces, or they're made of some kind of fragile material. But most places aren't using stuff like that unless it's on something really, really secure they're trying to protect. And so usually a lot of times it's not so like if you can peel it up, but it ends up with some little marks on it, or it looks a little crinkled when you peel it up. But if you reapply it, you can kind of smooth things out as well. So you can kind of just, it's almost like a little bit of an art to try to place it back on and smooth it out.
Okay.
But
so mostly heat, it sounds like, is probably your number one tip.
I would
like
say
a hair
heat.
dryer or a hot plate.
I usually have a heat gun because of like, heat shrink tube and stuff like that. It's just whatever heating source is around, but something that's very gentle, slow and patience is always valuable, because once you got too much heat, well, it's too, game over, right? Whatever, it's messed up. So you have to you kind of have to feel out what's going on.
For some of the more the tamper evidence stickers, like the ones that rip out and say void or whatever, the way I was taught some of these things in DEF CON, acetone and syringes, and you can inject acetone under the sticker, or you could probably do IPA, like alcohol as well, and it'll kind of unstick, but the glue is still there. So the sticker, once the acetone evaporates, it's sticky again. So then you can put it right back after. But it, like you say, patience, slow and steady is the biggest deal. Like even if you have all this other chemicals.
In anything reverse engineering is usually buy 3 of them because it's going to take you 1 or 2 to figure it out, right?
Absolutely.
And so it's the same thing. You know, if it was something I was going to actively attack on some other, it's like if you only have one. That's hard. That's a whole challenge.
Yeah, that's what
itself,
I was saying.
Right?
It goes back to the fridge problem that Elle and I have in her book.
What is it?
So there on Alicia White, who does the Embedded Systems podcast, when she wrote her book, one of the questions at the end of her book is the refrigerator problem, like how to determine whether the light's on and off. And one of the aspects of it is you get bonus points if you don't destroy, if you do all your testing using one refrigerator as opposed to like infinite number.
Yeah. Because reverse engineering, it's like most of the time, like I tell people, it's like whatever it is you're trying to do, buy 2 or 3 of them. And if you can't afford 2 or 3 of them, then you probably shouldn't be working on the first one because it's going to get destroyed in the process.
Yep, that definitely happened with those LED purses. Those like that I think
that's also what the Bunny Huang recommends. Like take one apart completely, then you can look at the traces, you can look at the components, then you have a second one to like poke at with like soldering stuff and trying to intercept things or inject, and then you have the pristine one where you can verify. This is for like exploits or for trying to do firmware extraction, that kind of thing. You'll have like a brand new one that you can test your learnings, if you will.
Yeah, absolutely. I followed him for a long time. Like he's really good, and all the way from I got his Hacking the Xbox book and all these things that I really encourage people to read because it really walks you through. And the same thing with these smart meters that I'm doing, I have a ton of them, but rip some down to circuit boards. So you just have a bare board to tone out traces and random things like that, right?
Does that mean that you're going to have a book on this?
I don't know if I have the patience for a book. I'm more video oriented. I would say I would make a whole video series probably before I would write a book. If someone that likes to write books,
I was going to say you need a ghostwriter.
Partner with somebody that likes to talk about smart meters, then maybe we got like a match.
I think if you just have like you have to is it RITMO, like the National Month of writing? Yeah, you just find some person who's really interested in doing a book, and then and they pair together for that month and just make a book.
Or do the Google YouTube transcriptions.
Chapter 1. Because I have to agree with you. Like after like the first page, I'm like, this is taking too long. Can't I just transcribe?
God, there's a book I just got recently. I was actually tweeting about it. Colin O'Flynn. The one him and this other guy, I wish I could remember his name, wrote. That book's amazing. I'm just reading it and I'm like, the amount of time that must have been spent to write that book is, otherworldly.
I got the early digital one. I was going through that. The pictures are really, really help demystify. Yes, absolutely help demystify a lot of the issues. What's the second author's name since we name checked one, but not the other?
Jasper Van Woudenberg and Colin O'Flynn, the Hardware Hacking Handbook.
Which is available on No Starch.
That's it.
Except no substitutes. Yeah, you should get one, Alvaro. I'm surprised you don't have this one.
I'm behind on life.
It's like I have the digital copy. I will lend you my digital copy.
Oh no, I don't mind getting it. But there's another hardware hacking book, and I think it's like a multiple. I'll have to find it, but yeah.
Yeah, someone I tweeted about it. Someone asked me like, is it worth it or whatever? And I said, look, just for the fact that it's structured information that has been kind of reviewed and put all in order. And I was reading the thing from front to back, even the stuff that I kind of already thoroughly feel like I know, just because it's like, these are 2 people that are amazing that took the time to condense this down into a book. It's like, there's possibly something I have to learn there,
It was good. I really felt like, yeah, exactly. Like you think you know some of the things, but there's little extra sprinklings of extra knowledge in there. They're totally worth it.
Yeah.
It's going to be a classic, I think. Don't quote me. Well, feel free to quote me. I don't really care at this point. It's going to be a classic.
It's on. It's being recorded. We don't need to quote you. We have the evidence.
So I had a second question about the Lidar. Now, there's a problem that the iRobot vacuum cleaners have, and it's quite well known, where its method is to bump into things, but some things are less elastic, less firm, let's just say. And what ends up happening is those things, yes, very smearable. So does Nito actually solve for the poop problem?
Yeah, so I will say, since I'm not a representative of the company, I can't be for sure. What I can tell you is that if it does drive over poop, it'll leave nice structured lines on the carpet as opposed to unstructured driving. So you will know where the poop was initially, and then and which path the robot took to fully kind of rid itself of the poop.
It won't be randomly distributed.
Yeah, it won't be a random distribution of poop. It'll be very structured.
That is just like my nightmare. That is my nightmare in all. Like I think this is why the robot revolution, the automated home, has not really taken off, is because we haven't solved for these types of issues that are naturally going to happen.
The soft skills.
It's solved for small groups, right? Like me, dogs and cats and everything. Sure, that's easy.
People who live alone,
in an apartment, no problem. Whole families with those environments, you're good.
You have hardwood floors. People who are dedicated to their jobs like all the time, but also are really concerned about cleanliness, then yes, I guess you're in the target market. I don't remember which TV show I was. I think I was watching. Maybe one of you two have watched this, but it only had one season. Arturo Castro's Alternator a Latino. Man, it's a tongue twister for me. But he had one episode where he was a android, and they made him like very error prone because it made it more comfortable for the humans, and had really bad self-esteem. So there wasn't any chance of them having a robot uprising.
Emo robots.
It was very emo, and he went into the kitchen and said, "Oh, I'm really bad," and then like suddenly he got like. He's like, I don't know how I'm going to take over the world. And like all the other, like there was like a Roomba and everything, like they're just sitting there like, like kind of rumbling with him.
That's
really
hilarious.
I have not seen this.
I'll find a clip. Maybe if we can find a clip online, because it's a really brilliant show, particularly if you're Latino, but like for anyone who's immigrant. But this one, I think, really hit me right in the heart.
It sounds like that big, in that, I've read the book, but in the movie version of The Hitchhiker's Guide to the Galaxy, there's this kind of big, like depressed robot that wanders around. It kind of sounds like that guy.
Yes, which was voiced by the late Professor Snape. What's his name?
Rickman.
Gosh. Yeah, Alan Rickman. He voiced him. God,
that works out.
But yeah, there's a long history of sci-fi movies with really depressed robots involved. Which I guess is a strategy for the future. So I'll take it that problem has still not been solved. It is contingent upon roboticists to solve this particular issue.
The key is to get all the engineers that work at whatever the company is 2 dogs that are not potty trained, and they will solve that problem very quickly. So there's one guy that I ended up. So there was literally one guy at Nito that when we were doing all that reverse engineering, that company actually thought it was really cool what we were doing, which was nice, as opposed to maybe how other companies view it. And so one of these guys, when I was reverse engineering the board and I'm taking pictures and we're all trying to figure out all this stuff, I found the pin that if you short it to ground, it just wipes all the firmware out of the thing. I was like, dang it, right? My main board. And this guy was so cool. He was on the forums. He reached out to me and he said, hey, if you ship the board back to me, I'll reprogram it and ship it back to you so that you still have something to work on, you know?
Nice.
And I thought that was really cool of that guy.
Yeah.
No, that's really nice. Yeah. My impression, having known some of the Nito people, was they were generally a pretty family oriented, a close knit group of people who are pretty geeky. Yeah.
I feel like most engineers would be fine with it. It's usually management and the business that are like, no, intellectual property.
Yeah.
This is why we have that.
Yeah.
People probing around randomly serves them right.
Yeah.
They were probably forced to put that in there to, like, you know, have like some legal coverage for trying to protect their.
I don't even think it was as complex or as well thought out as that. I think it was literally just a jumper that it was unlabeled, and I figured out what it was, and then labeled it for everyone else. Like, don't do this.
Don't do this.
That's pretty. Yeah, that's very valuable for the community.
Yeah. Be curious, but not curious over here.
Yeah,
on that jumper.
Yeah. So I think there are probably people in the audience that they're tired of hearing all of these things, which I think has been fabulous.
I love
personally.
Yeah.
But
we want some smart meters, is what you're saying.
Yeah, we want some smart meter stuff.
So, at the intro, jump to 47 minutes and 32 seconds for the smart meters.
Warning.
I just started doing the bookmarks now for editing. I don't know if you noticed, Jen, on the last
I saw that.
Oh, yeah.
That was the first time we've done it. So.
Oh, that's cool.
Because we had a really long episode.
Well,
I know. I listened to the whole thing.
It was fun. I just started doing a different editing program, and it was very easy to do with that. But anyway, yes, smart meters. How did you end up doing that?
Yeah, so I'll say it started one way, and then it kind of has turned into something completely different, I guess, as all things do. So when I moved to Dallas, like I said, I was kind of from a smaller town in California. I moved out to Dallas, and I thought, wow, I'm in a bigger city now. I wonder if there's other kind of like-minded hackerish type people that are out here. And so I ended up like searching around, and I think I found somehow this group on Meetup that was called the Dallas Hackers Association. And I went out to that, meet in person once a month, and people would mostly cybersecurity people that were talking about different things. And so I went to that for a while, and in one of these meetups, they were talking about kind of communication devices, like, and protests and things like that. So there was protests in different areas, probably around police related things or something. And people, potentially shutting down the cell phone network or having these Stingray type devices that can listen to things. And so what happens if they're disrupting kind of lawful protests using these means? And we were kind of chatting, me and some of these other guys, and thought like, what other kinds of networks could you build that a group of people could build? And there's Wi-Fi and there's all these things, and could you Bluetooth between devices? And I thought like, well, power meters communicate, and it's not likely you would black out a city to stop communication. And so what if you could build a device that could communicate across the power meters network that they have? And so I decided to start to go back and research, like, how does this network work? And could you build a device to do this? And as I started to research it and try to understand this, I read some interesting things that, they use what they call a geographical routing protocol, which is how these meters send their data back, so that they're somehow location aware. And they transmit to say, I want to go back to wherever the power company is. And as they send a message, it's somehow embedded in that message. It knows which direction to go to get back to the power company, which other meters in this huge mesh network, they all form a big mesh network, which other meters should relay their messages that are in the proper direction. And the ones that are not in the right direction, just kind of ignore the message and say, oh, I can't help you get closer. Right. And so that made me think like, well, maybe I could craft a message somehow that could hop onto this network, have maybe a TTL, that was just the right number, so that it gets discarded before the power company ever sees it. And you kind of end up riding on a network without anyone ever knowing. And I equated it. I gave kind of an in-person presentation to the Dallas Hackers Association that was never made public, because at that time I was not talking about anything like this publicly at all, for fear that just, the government would descend upon you and you would be disappeared, and that was it.
Spoken like a true Texan.
Yes. And and that's even pre-Texan. Like, that was my California mindset saying that. That just critical infrastructure you should not touch at all or talk about publicly.
Yeah.
Mm-hmm. And so I equated it to like, freight hopping, like a train's going across town, somebody hops on the train, they hop off the train at some point. That didn't do any damage. They didn't hurt anything. Mm-hmm. No one lost anything by that event, right? It's just someone was able to move across an area. And so I did a lot of research kind of in that direction, just to understand this network and how it communicates and everything. Now, February of this year, there was kind of the great blackout in Texas, and a bunch of us lost power for a long period of time, and it, it's kind of a scarring event. Like, and that's when it was right around that time I realized that, and I'd been looking at these meters for kind of a years up until this point, on and off, and I realized, we need more people need to be looking at these things publicly and talking about it and presenting how they work and putting it out there so that, if there are issues or anything that's wrong, that everyone knows. Like, it's wrong to ignore it and to not look at it and to have this weird stigma around it. And so it kind of started as a fun thought experiment of like, I wonder if you could craft a message and hop it across the network. And then as power went out and I realized, like, I don't know if all these guys really know what they're doing around here or anywhere, it became more of a journey of, are these systems secure? Are they being upgraded as frequently as they should? Are they being taken care of? And who's really looking at that? And how much does the public know about how these systems actually work? And how much do the people that even run the systems and own the systems know about how they work when you get all the way to the edge, and it's these networks that are kind of private and undocumented, and you can't find anything out there about how they work, what the protocols are, or anything. You have to reverse engineer the entire thing.
So it seems like you're kind of taking the stance that many people in the security community have taken regarding voting machines, which is it is a public good, these public utilities, and we should understand what's going on with them, how they're protected, how they operate, for the benefit of the public who is the primary user of them.
Yeah, I mean, I think it's critical, it's in the name, right? It's critical infrastructure. If it fails, it's a horrible event. And it seems to be that the thought is that no one should touch them or talk about them publicly, or no one does for whatever reason, maybe for fear of companies wanting to silence you or things like that.
Yeah.
But all of us know the more something is attacked, the more it's looked at, the more resilient it is.
Yeah.
By the nature of having to withstand the attacks and withstand the scrutiny of eyeballs on it. And so when you remove both of those elements, you have a recipe for disaster, right? Over a period of time, things become easier to hack. The longer something exists in the world, the easier it is to hack, right? Because all the other technology that's needed to hack it advances. It becomes cheaper to buy. All these software-defined radios, all the tools you need used to be tens of thousands of dollars 10, 15 years ago. Now they're sub $1,000, and imagine how much they'll be in 5 or 10 years, right? It'll be dirt cheap, to get this stuff. And so it's, to me, it's important that stuff's looked at, right?
Yeah.
And so I've kind of focused in that direction now.
Yeah, actually, you made a really good point that I didn't touch upon when you had mentioned it, when you were talking about like getting that job where they wanted you to have an oscilloscope and you're like, oh, I'll just read up on it. That for a long time, access to an oscilloscope was such a gate to the industry.
Oh, yeah.
Because those were hundreds of thousands of dollars, very few people had them. And just like you mentioned, the fact that access is so readily available now, you can buy, the consumer public can buy them pretty inexpensively now, means that, yes, it's a lot easier to go ahead and hack.
Yeah, I mean, today, anyone that wants to own an oscilloscope today can. Like, there's no reason you can't. You can get them for like $30-$50 on Amazon for the really tiny ones.
Yep.
But you can analyze things and see what's going on. When I was a kid, it's like I had a logic analyzer. There was that little thing from Radio Shack that had a red LED, a green LED for high or low, and a little LED that said if it was pulsing or not. And I would try to decipher serial protocols and write my own serial protocols and figure out the baud rate and everything with no oscilloscope and trying to just do the timing. I mean, you talk about like, that is hard, compared to just an oscilloscope and measure the waveforms and be like, oh, I'm off by a little bit. Let me tighten up my loop or whatever, right?
Yep.
Wow.
Absolutely. Yeah, it is amazing to, like, you really hit on the point, which is like, yes, the ability, the tools that are there, and as well as the scrutiny. So when I think about Windows, the operating system today, and the amount of shitty scrutiny, the amount of shitty marketing that they've had or publicity that they've had because they've been hacked, they're so easy to hack and so on, has really made them have to be on top of their game in terms of security, protection, et cetera, et cetera. Not saying that they're perfect today, but now the scrutiny is now turned towards like all the vulnerabilities in Mac, which has historically been seen as more secure, but now we're starting to find more security holes there. So it's doing a lot more updates to protect itself.
I hear this in other podcasts, and it's like attacks always get better. They will never get worse, right? Like more computing power, like you say, cheaper equipment, new algorithms. Like it's never going to get harder to break into or break something. It's always going to get easier with time.
Yeah, it's always better, faster, cheaper, right? And so the tools and that's why, militaries and everything spend a ton of money to stay way at the cutting edge of technology, or 5G comes out or something that's, a much more advanced technology, because then the attacks and the cost of attack is greatly increased, but that doesn't last forever, right? Yeah. The cost of attacking frequency hopping spread spectrum systems, like what these power meters used to be incredibly high. They're across like 26 megahertz. They're hopping all the time, every 700 milliseconds. That used to be a crazy thing to try to figure out an attack. Now it's much easier, and I've written stuff using free GNU Radio software to do it, using pretty moderately costed SDRs and some even lower costed ones. And that's, that's basically not valuable at all anymore as a way to obfuscate stuff in that sense. And so, and then, like I say, going another 5-10 years from now, who knows how cheap and easy that'll be. It'll be a Raspberry Pi or something that can do all of that, maybe with some built-in RF hardware. Who knows?
And the meters are going to be the same, most likely.
That's the
probably.
Thing. Yeah. So the ROI, the return on investment for power meters, is 15 to 20 years.
Oh wow!
Which means when they buy it, it needs to sit in the field for a minimum of 15 years. That's how that's how it's costed, right? Mm-hmm. And then hey, if it can last 20 years, what the hell, right? Better ROI. Yeah. So think of any microcontroller and think of it 15 years from now. And, has the bootloader held up? Can you dump the firmware out of it? Yeah. Is it still as secure as it was? What about just microscopes and scanning electron microscopes that can look at that level of, the however many nanometers the silicon is, anything like that? All the stuff you would need to attack that 10 years from now might be way more accessible, available on eBay. Some college is selling their old equipment for scrap that you can pick up and now set up a lab in your garage. Yeah. There's a ton of ways to attack that stuff, right? And so fundamentally, I kind of think that business model might be flawed, right? And so there's probably a lot of things that you kind of discover along the way that are just, as I dig into it more and more, you see all these interesting things.
You mentioned, the future, we're going to have more of these devices are going to be available in the market. And that means for example, you can buy more of these on eBay and start looking at them. So I guess that just, I want to ask, how did you start looking at these? Did you immediately think, can I just buy a no power meter on eBay and it's going to work? Or what was your approach to start looking into this? You were interested in it, but how did you go about, I'm going to figure this out?
Yeah. So I'm I don't know, touchy-feely is not the right word. I need to take things apart, and I like hardware, right? So I can read a little bit and read, spec sheets or whatever, but I want to take something apart, and so the first thing is, well, how do you get one of these things to start analyzing it? And so it's not, anyone can get one right now. Like, they're on the side of every home and business and they are not locked, right? Like, there's a little security tag so the power company knows if someone's tampered with and tried to take it off, but it's pretty easy to unplug and just walk away with it. So if you wanted to just acquire hardware, like say I was, malicious attacker, you can just go get one. They're super easy to get and no one's watching if you take it or not. But I wanted to make sure that I was doing everything on the up and up and I could actually talk about what I'm doing publicly. Everything you'll see in my videos, from Faraday cages to all these things to having an amateur radio license, everything I've done has been to ensure that I can openly talk about this and someone can't just attack and shut down what I'm doing over some little kind of thing, right? So I thought, I can't take one, because that's not going to work out. I can't just steal one. And I can't look at the one on the side of my house because it's like a cable box, at least if you're renting it. Like, I don't own it, even if it's on my house. So I thought, well, where could I get these? And so I kind of defaulted to eBay from buying cell phones and older kind of things and just shopping around. And so I went there and I typed in like smart meter. And I was just amazed at how many of these things were for sale. And even the one that I needed, like Landis and Gear, Focus, AXR-SD, like that specific model, and a whole bunch of different ones from different cities, all for sale on there, along with a bunch of other hardware you see that I've managed to acquire. If you're watching these videos, like modems and collector devices and all these other things. And so, I was just boggled. And so this was a couple years ago. I bought one, and then I just started buying more and more and more because they were pretty low cost. And I bought with the intention of, especially once I realized I was going to put this stuff on YouTube, and once I realized I was going to talk about it publicly, I basically just bought as much as I could, figuring that source might get shut down at some point
Oh, good.
by someone. I don't know who. It'd be a tough challenge, right?
You basically stocked up before either.
So I stocked up to have everything I would ever need. So if someone says that source dries up, that's not my problem anymore. It's so, but it hasn't dried up at all. There's still, you can hop on there now, and there's all kinds of power meters and different things. Some of the really good things that used to be there, I bought all those, but there's still a good amount of devices on there.
Yeah. I had, going back to some of your discussion around like how I guess municipalities or utilities are amortizing the lifetime of the meter itself of like 15 years. Like that's really short compared to let's say what's typically happening for, particularly in power utilities, it seems. So if you look at California, PG&E itself has had basically some stuff has not been replaced, and it's over 100 years. And we've had like numerous failures that have caused fires and so forth and so on. So like I think the problem's even worse. Like some stuff just there ain't nothing on there. And the smart meters themselves, I thought, have only been rolled out in the last 10 to 15 years anyhow. So it seems to me like this is a problem where either you basically have to require these companies to do this on a regular clip, or you have to basically make them companies run by local government to force them to have that kind of regulation. And
that's a huge challenge. It's probably, it's like I could speculate on things, but I'm definitely not one to discount the level of challenge of what this is, right? And the cost, and ultimately that cost is, borne by the consumer themselves. So if we want new meters every 2 years, guess what? It's like that's rolled into the power bill. Like it's not like they're free or something, and then you have to say, well, what's the value to the consumer of these things? Because that's the question then the consumer asks. Like it might be making your life easier and you more profitable as a company, but does that really do anything for the consumer? But to your point about other things like the really big transformers and all that stuff, the ROI on those is much longer than 10 or 15 years, and I think it's the challenges as they start to slap on these kind of network enabled stuff or internet enabled these different devices. That's when it becomes, when the ROI, those calculations probably have to be different, because you can't network enable and internet enable things and expect that even if the hardware would last 100 years, that you could, that should be the way it is, that you should
the
have
maintenance
some really,
cost.
And that, knowing that it will be hacked if you deploy some system like that there's only so many firmware upgrades you can do. There's only so many of these things before it's just the attack surface will be too great, and the way to attack it, so that's a really, it's definitely a big challenge. But I think that's part of the thing, is that it's not being highlighted, I think, because people aren't openly attacking it. And as you openly attack it and say, well, if some ransomware actor or someone else wanted to come up with a firmware, you can update the firmware on these things over the air wirelessly. And you can attack them a bunch of different ways. If somebody wanted to just, say, hey, we're going to black out a part of the city and we'll black out the rest of the city unless you send us, 500 Bitcoins, right? Like as that becomes easier to do, and the barrier to entry of the hardware and everything else becomes lower, it becomes an attack someone's willing to do. And because these things are rolled out all over the place, it's like if you figure it out in one area, you could probably figure it out in another area too. And so
there's a guy that who worked in IT at a large corporation that I knew of, but before then he was working for, I don't know if it's I think it's maybe Department of Energy, and all he was doing as an IT person, I guess he also was a regular at Black Hat, but he was saying how like the government has an entire side or team of people who are mostly volunteers, shockingly. All they're doing is protecting our electrical grid from counterattacks or from attacks. And that was, 2009, 2010 when I was talking to him about this. So no doubt it's gotten way worse, and we're way past. I would imagine we've probably already had that type of ransomware attack
Yeah, and when you look at, there's all the SCADA devices, and there's a whole other group of people that are
Yeah.
looking at SCADA devices, and they ride on kind of the internet and what
Hmm.
attacks can be done there, and how devastating those things can be attacking
Yeah.
those types of systems. I focused more on the wireless side and this other part of the network that I felt like was being ignored.
Mhm.
And I also always enjoy wireless because, and I think it's good for people to know, it's like if I didn't want to publish anything, it's like if you're smart, you can attack a wireless system with no one ever knowing
That's right.
that you're doing it, especially if you're just receiving. You could completely reverse engineer a protocol and attack something without anyone, or not attack it, right? But understand how it works without anyone ever knowing you're doing it, which is different from an internet based attack where you're sending packets across a network and people could see what's happening, and you have to go to a lot of steps to bounce things through or whatever. Yeah, you're on it though. But when you talk about wireless things, especially old school days,
Yep.
satellite TV, or you talk about, these kinds of networks, I mean, you can just, you can sit around and just hack that thing all night long and think about it. And even if you go to transmit, it's like, can they triangulate and figure out where you're coming from and all these things? It's like, not really, unless they're prepared and they know what you're doing.
Yeah.
So it is, it's a different kind of attack surface. And so people, it's good to help them understand, these people that make the decisions to buy these things and roll it out, like what it really is. It's not as secure as, a lot of times as people wish it was.
Yep. One of the things that, going back through your videos earlier this week, that I thought was interesting is that they, if they wanted to, they could tell what appliances were running in your household. And naturally, like to some people, they'll be like, oh, so what? This is like really a benefit to the whole community in terms of making sure that people aren't consuming more than their fair share of power, especially during, let's say, the summer or the winter. Do you have any evolving thoughts on how they might end up using that, or like how fine grained can they make this information be? Because like it's kind of disturbing if they know that you're charging your phone all the time, I guess, or if you're maybe Bitcoin mining, maybe, I don't know, or making
Yeah. So
NFTs.
Yeah, so I think so the meters, like there's so many different manufacturers of these things, and then on top of that, like the boards and kind of the different technologies that they're using, like as far as how they transmit, I guess you could say.
Yeah.
There's just a lot. There's not really any. I mean, there's standards kind of that they apply to, but everybody's got their own. And so there's a lot of different ones out there. So the ones I've looked at, these ones by Landis and Gear, I
Hmm.
kind of researched and to see, well, what are the newer models they're coming out with? And so some of the newer models, there's a company called Sense, I want to say it is. They sell like a current measurement deal you can put on your house, and it'll give you those levels of kind of very fine grained power readings. So
Hmm.
they're reading it like, 15,000 times a second. They're measuring current usage and very fine, this company Sense. And so they can tell you like, oh, you're running um, your refrigerator or your air conditioning
Mhm.
unit, or which air conditioning unit, or
Hmm.
your dryer or something like that, because they can look at the signature kind of the device has on the power line as it turns on. And so they can capture it, have a snapshot of what that signature is, basically looking at the fluctuations of the power lines,
Hmm.
and then figure out kind of from sending all that data probably back to whatever cloud they have, what matches, like, oh, that's a
Yep.
Samsung refrigerator,
Yep.
that's the way they turn on, or whatever else. So if you look, Landis and Gear is a company, I believe, you'd have to fact check this,
Yeah. Yeah.
but I would say they have an investment in Sense, or
Hmm.
they've acquired them, one or the other. And so they incorporated a very similar technology into their latest meter. It's called Revello. And so when you look at their marketing videos,
Hmm.
for Landis and Gear and their spec sheets, they talk about basically the exact same specs as what Sense had on their current detection things, so that the meter itself could detect all these things. And so they're talking about ways to deliver to the consumer, maybe knowledge of what devices are turning on, how much power you're using, when you're using it, all these kinds of things. Everybody's got a desire to create some kind of app ecosystem
Yeah.
or something
Yep.
that the
Yeah.
Yep.
consumer would buy. I would say, I think of a lot of that stuff is it's kind of, marketing to try to get the consumer on board to maybe say, hey, here's why we should get new meters. Because when you look at these meters that came out, it was like, oh, the consumer's going to have all this information and they'll be able to, save power and everything else. And we'll have portals for them to look at this stuff. And most of that stuff never seems to materialize. It becomes a great, marketing effort to sell whatever it is. It's like, oh, your car has Bluetooth this and yada, yada, yada. And really you're just going to the store and back and you don't use the other 100 features that the salesperson's talking to you about. I think these systems aren't really that much different. They need to help regulators justify why should we spend tens of millions of dollars or more to upgrade. And it's like, oh, the consumer's going to love it. They're going to have all these portal features and they'll save power and things. And, I don't know how much of it, like how much value is it in a power company if you teach everyone how to use less power? Like that sounds like it cuts into profits a bit,
Yeah. To be honest with you, like I that's the way, like I was very skeptical and dubious that any consumer would find a thermostat sexy or useful, but we got Nest.
So I think some things though, like when I looked at Nest, like when I had a Nest at another house, now I have like 3 air conditioners and the ROI on Nest for me is not so hot with 3 of them.
Yeah.
But the value for me in Nest was not all the learning and everything. I had it. It never it never quite figured it out, but it was great to have an app on my phone that I could lay in bed and adjust the temperature like before I got out of bed. And so I think there's certain things that definitely resonate, like being able to program that, have it turn things up and down. But I'm not, I guess it all depends on how it's rolled out, and what the value is.
I feel like the kind of what you were getting at is on one hand, it sounds like you have this one company. I'm confused about which one was Revio or
Revello. It's Landis and Gear that makes, and they call it, that's their line of meters.
So I'm kind of wondering if what's actually happening is like, hey, consumer, put this thing at, here, and then we'll give you personalized, updates so you can help save the planet. Meanwhile, all your data is getting siphoned up for their machine learning algorithms to go, okay, there's a whole lot of Samsungs, a whole lot of this and that and the other. And then they end up using that data to feed a new thing that's going into smart meters that's more on a B2B side. So that's what I'm kind of wondering is if they're kind of like, they have the consumer front and then a separate B2B for the people who are rolling out these meters.
For sure. It's quite possible that the, data could be sold of, what kind of a person is this? Like, what do they use? How many devices they have? Yeah. Do they have a Tesla or not? Like that's going to have a certain kind of charging profile. I have welders, when you start welding, that's a certain kind of, high draw or whatever. And right now, that's, you don't really have that granular detail. What they have is, this person kind of uses a lot of power, and they could probably tell a car because that would have a certain profile of a good amount of power usage over a period of time, but you can't tell the very granular things. And these devices, as they advance, it gives whoever can receive the data. So this is assuming that only the power company gets the data, right? And they know they have these great vaults that they store your data in, and never shall it be released.
I was just going to say,
right? And we all know how that ends, and like I can tell you that data is probably transmitted back wirelessly somehow. And, how secure is that, and who, can your neighbor with an SDR receive all that stuff?
So I'm kind of wondering okay, so we have consumers who don't want to pay extra for anything. Power companies are like, okay, we got all this extra data. Consumers don't give a rat's ass. They're still going to use as much as they want. Okay, what if we sold this information to third parties? And this is kind of where I'm wondering if what happened in Texas that February night is that people had enough information to go, oh, the load here is going super, super high. Why don't I start buying up stock or shorting this or that or the other in the market so I can make a little bit of extra money because I know shit's going crazy on the grid right now.
Yeah. And, that's like kind of the Enron deal way back in California. I was in California when there was like, I'll do the air quotes right now, the blackouts that really weren't blackouts at all. It was people playing with demand and saying, hey, if you can shut off power here, that looks really good. And we can sell it for a higher value over there. And there wasn't really anything going on when you read, back to some of those kind of, blackouts in quotes, right? It was Enron playing games and traders, selling power for more money because they were removing supply from the system. So then the demand would go up and you could sell it for a higher value. I think out here what happened is just people aren't they aren't building the systems resilient enough. Like these, we know it gets cold a couple times. It's already happened. It's going to happen again. Yep. And, it costs money to invest for the really bad times. And so it's just a simple analysis that I'm sure they teach in school.
Oh, they do.
It's like, hey, if it doesn't happen that often, and when it happens, it only costs you $10 million
Yep.
in fines or fees, but it costs $20 million or even $5 million to do the work. Well, if we're not sure, it's like, it's just it's a spreadsheet,
So
and
it is literally a spreadsheet. It's called expectancy theory. And so what you do is you take the monetary value of what it would cost should this event happen times the probability of that. And then you compare it against the remaining probability times what it would cost otherwise. And then from there you add those. And that's how you kind of know which route to go in your decision
If all
tree.
you care about is money.
If
And
this was taught in a business class, making business decisions.
Yeah. And it's important for people to understand. Yeah. All a company cares about is money. Like everything else is marketing and ways to hire employees and everything. Like it's just money at the end of the day. And so if you allow the market to make the decision, the market will make it based on what the market cares about, which is investor return. Right.
And in this, and then in our capitalist society, a corporation is required to return value to the stockholders and to the owners of the company, not to anybody else. So unless you legislate it as such,
that's it.
It's not going to happen. Okay, we once again went ethical and
All right.
went way off.
I'm going to ask now about tools. So, because this is what I like. So you got these meters. How did you go about figuring out the protocol? You've mentioned SDRs, you've mentioned Faraday cages, but what was the process of like, okay, I've gotten these things from eBay. How do I figure out what this thing is transmitting and what does it mean?
Yeah, so it happened kind of over a good period of time. I would say when you like some of my early tweets, I think I have one that says like, hey, I'm working on reverse engineering smart meters, and it's a good way to learn software-defined radio in C++. Like I'm kind of always looking for a reason to learn something, and a project is a good way to focus yourself down. Like, oh, I got to meet this goal, whatever it is, and so I'll learn what I need to solve this problem. And so for me, that's I enjoy it. So I started focusing down, and I always wanted a reason to really dive into software-defined radio and GNU radio and other tools like that. And so when I started with the smart meters, the first step was just receiving the wireless data. And like I said, they're hopping around all over the place. There's basically 240 channels. So you can think of it like, radio stations, you flip from one to the other and you choose what you're listening to and it stays in its same spot. These things, the meters, the radio station's hopping around on you every 0.7 of a second. It goes to a new channel. It has 240 different channels it can pick from, between basically 902 to 928 megahertz. Mm-hmm. So the first step was trying to just receive some of those packets of data and figure out what is even going on with it. How's it encoded? What's the bit rate, all these things. And so I used a few different devices. The first one that I actually was able to receive some data with was like that Michael Osman,
Hacker.
The great,
Yep.
No,
Hacker.
it was not the Hacker, it was that yardstick.
Yardstick one?
The yardstick one. So the yardstick one uses the same transceiver chip that the smart meters use.
Oh, cool.
This Texas Instrument CC 1020.
Yeah.
So you can just use a little Python script. I would just set it to one channel, and eventually the meter will hop to the channel you're listening to and transmit if you just let it sit there long enough. Because in order to pass, FCC certifications, everything, you want to hop equally across the entire band. So you don't really want to favor one channel. So you just pick a channel and let it sit there, and you'll hear data from meters around you. And so I started capturing some packets, and then it was using tools like, now it would probably be Universal Radio Hacker to take that. There's another one. It's not Baudline. It's another one. It's a visualization tool. It'll come to me probably in a minute. And you can capture some spectrum, and then you can look at it. And I've used that with some software defined radio stuff to capture the spectrum and then look at, how it's modulated and what the bits are. But with the first way I figured it out was with that yardstick one. And so I was able to get the kind of the bits out of it, see what they were, and then, kind of stare at the ones and zeros until you figure out, okay, this is the header, this is a bit of a preamble, these are these different pieces. And it was really just capturing quite a few packets, some Google searching. I did manage to find one analysis that had been done by some other power company, and they had some hints in there about like what the header is and some other stuff that kind of helped me get those pieces figured out initially. So I would say a lot of software defined radio as far as tools. Like if you look at my stuff, HackRF, Blade RF. I have an Edis USRP B200. That one really lets you receive, and all of them, with most of the software-defined radios, is just how much bandwidth do you want to receive at one time, so you can listen
Yeah.
to kind of all the hopping. So that, as far as tools,
What was the other one in Spectrum?
in Spectrum, yes.
Yeah, I just wanted. So, are these all Great Scott Gadget ones, or?
No, so the Yardstick one and the Hack RF
Mhm.
are Great Scott Gadgets.
Mhm.
And then the Blade RF is Newand.
Yep.
I think that makes that one. Edis, which now is owned by National Instruments,
Oh,
makes
okay.
the USRP B200.
Yep.
That one I like a lot. That's a good tool to work with. It's a little pricey, but it's
National Instruments is kind of pricey.
Yeah, it's sub 1,000. You can maybe
Okay.
get them used on eBay. I got mine for like 500 on eBay, I want
Yeah.
to say. And I just really, really wanted one, so I kind of ponied up. And then I also have, oscilloscopes, logic analyzers. I've heard a number of people mention the Saley, I think is maybe how you say
Saley?
it. Yeah, that one is, I like theirs. I like their software. It's pretty good. I have a bus analyzer. I've been using that more recently. One of these Beagle I2C and SPI.
Yeah,
That was good. I captured some of the traffic between like the microcontroller and the transceiver, the radio transceiver chip. What else do I mostly focus on? I would say,
the Beagle stuff is real. I really like. I've used their stuff for USB analyzing, and it does a great job.
Yeah, it's real nice. I mean, and that was nice to just confirm that they do hop every 700 milliseconds. And I was capturing all the channels they hop to try to do an analysis on the frequency hopping side. Like, could I also build a frequency hopping thing to hop along with the meter? They hop based on their network ID, and part of their kind of MAC address is how they determine their hop pattern.
That was the question I had. Was what? How did you figure out the equation there? And you just
I
answered
didn't.
that.
So what's really interesting is I still don't know how they hop. What I did was I built a receiver that no matter where it's hopping, it receives every single transmission in that whole range.
Yeah. So
basically on the receiving side, it doesn't matter where it hops. I receive everything and I decode all those messages, and I can tag it with the frequency it was received on and the time and everything. And then just very recently, I built a transmitter. So you got to think like, so I can receive the meter anywhere it goes, but how do I talk back to it? I have to know where it is when it hops to send it a message. And so what my thought is, well, could I build a transmitter that just transmits on all 240 channels simultaneously? So no matter where it is, it gets my message. And so I just did that like a couple weeks back.
Yeah.
And so I have a transmitter now that when I send out a burst on all 240 channels simultaneously, I've verified it with hardware I have here. No matter where I set the modem to on any channel, it receives my message every time I transmit it. So now I have a mechanism where I can basically feed all this data to like a Python script. As a message is received from a meter, I can receive it, parse it, build my response, transmit my response back within that window. And I now have a way that without ever figuring out what the frequency hopping pattern is, I can talk to anything that's frequency hopping.
It's like you're in a horror film. So you have 240 of your friends. Each one is picked. You're all back to, you're in a circle with your backs to each other, facing out. And you hear some ominous voice telling you something. And then you guys all decide what you're going to say back. And everyone shouts in their different directions, the same thing at the same time.
And I can parse all those messages simultaneously and put them down and then send a blast back, right? And so to me, so that's basically kind of rendering the frequency hopping portion of that protection useless. So now it's okay. There's a couple other pieces. They have some, some little things they use like any network communication where you have kind of like, what's it called? It's like, it's almost like some sync information. So they
like
have
your
kind
advertising
of a counter
channel, basically.
Well, it's like, they don't have that, but they have kind of like a counters they're incrementing and these other things. So when you communicate with them, you can't just fuzz it with garbage data. You have to build a response. And I've figured out quite a bit of that already.
Okay.
So I'm working on a script where I can basically receive it, parse it into the different pieces, like the receiving ID, the transmitting ID, all these other parts. So I can craft a response that the meter is expecting. It's got a properly signed CRC on the end of it and all these things, and then see how it responds when you're not just fuzzing it with garbage data, but you're really crafting a response that it's expecting to see. And so can I flood that network? Can I send it all kinds of garbage? So in my own kind of little network that I've built in my house, that's the test that I'm doing. Like, what does it do when I set up a meter? I have a device that is basically simulating the other side of the network the meter's trying to talk to. And then when I put myself in the middle of that or alongside of it, what happens if I just start flooding packets into that network, or if I send things, or can I change the time? Time's really important when you're billing power. Like what happens if you set it back by a day, you know? And it broadcasts the time routinely that the meters then make sure they're set to the proper time. Because for all of them to hop 700 milliseconds, everything, they all have to have the right time, right? And so there's probably a ton of different kinds of attacks that can be done there that I'm just now at the point where me or anyone else can initiate those similar kinds of attacks using these software tools that are kind of freely available.
So you keep saying your network. How big is your network? Are we literally talking just one, like your big array of antennas to like basically take in every single channel all at once and then just one meter? Or how many meters do you have in your network at home?
Well, I could probably have like 10 because I have a lot of meters. But right now I've just been doing a couple inside of a Faraday cage, and then an antenna coming from the software defined radio. Into there, and it transmits. And so it's very small, like, you know, kind of unassuming looking, because you can transmit it on 240 channels from just one little antenna sitting there. Like it's not this crazy science fiction looking thing that's coming at you. It's a very small thing that you would never guess that it's doing all that, right? And so for a network, what I need one side that's running kind of this collector device that the meter's trying to talk to, and then the meter, and those two need to kind of, like, when I'm listening to the data, I need to hear that they've kind of had a handshake. Like I can see the sending and receiving address, and I can see the meter sends a message to it sends a meter back, and they kind of discover themselves. And then a piece shows up in this software that I have kind of some debug tools for. So once I see that kind of connection's made, I can have 2, 3, or 4 meters in there that all kind of join this little network. And then now that they're on a network, they've synchronized time, I can try to send some attacks, and it would be, I feel, close to if I was attacking my own meter network, say that was in my neighborhood or some other network. So that's what I needed. I needed something that formed that little simulated network. Otherwise, I'm just kind of trying to attack a meter that can't find its network. And so it's not the same as what it would be like looking at devices on a network, right?
Yeah, it's funny that you talk about, it's not a ridiculous like antenna array, because just like in your video, you're like, once you know what you're looking for, just driving around, you start seeing them everywhere. And like the antennas themselves are not big. They're like everything is kind of blends into the background as it is. So that works for them, but it also works for you.
900 megahertz. It's like, those aren't big antennas. Like, it's, same thing. Like you look at Wi-Fi, a 2.4 gig antenna is a little antenna. 900 megahertz is only a bit bigger. And so it doesn't take much for that stuff to send. And because it sends these very short bursts, they can kind of be high power bursts, which travel quite a long ways. And it doesn't take much because it's just little packets of data that they're sending.
So for that particular range, the 902 to 928, I think you said, megahertz range, is there anything particularly special that the FCC has it licensed for? Is that just where?
Yeah, so it's like an unlicensed industrial, scientific, and medical. That's what ISM stands for, I think, band. And so basically, like, a lot of different frequency ranges, someone has to get a license. Whether someone has, like you look at cellular carriers and everything, they spend billions of dollars to buy frequency ranges. With this 902 to 928, I think it came about quite a long time ago, and it was a way for there to be these little devices that could communicate that, they have to be FCC certified, but there's no licensing requirements, which means you're in an unlicensed band. So you have to figure out how you get your traffic to travel across without other people stomping on it, because anybody can be in there. Power meters and all these other things are in that same band. That's part of the reason that they're frequency hopping and doing all this other stuff. So that if one channel isn't good, it just hops to another channel. And so, in that sense, I think it all comes down to cost. It's much cheaper to do that than it is to put 3G modems or 4G modems, which might be way more secure inside of power meters, but then you have to pay all the costs of all these devices on a cellular network and everything else versus
managing them.
And some, if you look in outside the US, a lot of them are 3G or 4G in the meters. Like it's not, they don't go with these kind of mesh private networks that there's no documentation for. They want public standards. They want it to ride on a cellular network or something, which I'm sure has its own challenges. But I think this is probably cost driven on these.
So I want to talk about a different kind of network, and you've mentioned Wiki, and I've also seen on your YouTube videos it's Recess Sim. I don't know what it's called, but it's like a
Yeah. So it's called Richessum.
Richessum.
And so I'll tell you how it came about.
Yes,
please.
Yeah,
Particularly the pronunciation.
Exactly. So Richessum is Latin for moving backwards, right? Which is what reverse engineering is. It's us instead of forward engineering, we're reverse engineering.
I thought it was an acronym.
Yeah, nope. It's just, and it also happened to be a .com that was available, which is basically what drives everything is what's available.
That's right.
.com, and so I had to look up the pronunciation, and I get it. It's everybody says recessum, and it's a challenge. So I try to say richessum as much as I can in whatever videos, and so that's its own kind of challenge. But it came about as I felt like I was always reading about these different people. I'd read about Travis Goodspeed or Chris Gerlinski, or there's this guy, Chris Tarnowski.
Yeah.
He's got a few videos. That dude's awesome. I love watching any video that guy has. He's so passionate about silicon.
I saw him live at Hardware IO here. Both of the Chris's were here. Yeah.
Yeah. And you're always seeing this stuff. It's all over the place. And I was like, it'd be nice if we could at least have a place where you can find out more information or more people come to one spot to share about reverse engineering. And so when I did the Nito XV11, I created a wiki. It was like xv11hacking.com. It's long gone. Because that site, I was using someone else's wiki. It was a company, I forget, Wiki Spaces or something like that.
Yeah.
That's long gone. But what I did is I created this wiki and I started documenting what I was finding on this robot, and a ton of other people joined this wiki and they were documenting, and we were all filling out this thing. I was like, wow, this is so cool. And it went away and I was bummed, and I thought, I'll build a wiki, but this time I'll own everything about it so that no one can shut the thing down, right? So it runs MediaWiki now. I pay for the hosting. I've got kind of cash set aside for, 10, 15 years worth of hosting costs. So it's not like it's going to go down for some reason. And I just let anyone join for free. There's people hacking and reverse engineering radio sondes, which are like those weather balloons that go up. And when they come down, they don't care if you take the hardware and keep it. So these guys go hunt weather balloons, and they're reverse engineering the hardware, and they have a whole page on the wiki documenting it. And so it's a way to try to, centralize some of this information for anyone that's into reverse engineering, to say, hey, who are other people that are doing it? Can I document my stuff there and share images and data and everything? And so that's kind of how it came about. Is I wanted a spot to put that, and I want a spot other people could come to as well.
And there's also a Discord, right?
Yeah. And so I created that because I had started with a forum. I think the forum's still up, but it just didn't seem to jive that well, And so I created a Discord after somehow else getting on Discord, and there's a ton of people that joined that channel too. We chat about reverse engineering power meters and other, any random things somebody wants to talk about. And so I kind of created some links off of richessum.com. At the bottom, it's just kind of a landing page, and you click a link, you'll go to Discord, or it'll go to YouTube or the wiki or those things. And so there's a number of us in there that will chat about the, anything exploits we're finding for smart meters, whether it's how to dump firmware in the chips or anything else. And that's actually been really good as a way to communicate with people.
That's awesome. Yeah. It's so nice to, be able to communicate and get help from like-minded people these days. And I feel like early days we had IRC, we had forums, and then I feel like we lost it for a while, and it's kind of coming back in the ways of Discord. And I mean, IRC never left, but a lot of people left IRC.
And I was on IRC early days in different kind of channels, and it was the same thing. It was a great spot to go and ask questions and and find out stuff. And so same thing with Discord. It's let people come in, ask questions, help direct them to whatever, if they want to join the wiki. It's like, hey, no problem, create an account there and share stuff. And so that's been pretty fun.
Awesome. I love hearing about this stuff.
So we've talked throughout this entire podcast, you've mentioned many times that you've gotten a lot of stuff from eBay. And from some of our past guests, John McMasters in particular, he said that there's a lot of power in going to eBay to getting some of your equipment. One, what are, how I guess I'm wondering is like, how difficult is it to find what you need on eBay? Is it worth it? Are the prices better? And did you ever figure out where all of this stuff was coming from? Like, how are people just having like meters that they're just selling?
Yeah, so so I would say yes, I believe eBay is a good way to find things. So I would say I think part of what happens is there's a disposal issue. So if you're a company and you have to get rid of stuff, you usually there's not a trash can they let you put it in. Like you have to responsibly dispose of things. And so maybe it's an e-waste
Mhm.
company. And if you're an e-waste company, it's like, well, you also are trying to you're making money when someone pays you to take the stuff. But if you're a smart e-waste company, you're making money also in the disposal of that
Yep.
stuff. And maybe you're disposing it on eBay. Like if there's not an agreement that says you must destroy this hardware, well, then you're going to sell it for as much money as possible. So I think a lot of times this stuff is, a company's trying to get rid of it. But if they're not watching how they get rid of it, it can just land on eBay. If they say you can haul it away and do whatever you want with it, it could land on eBay. Maybe some enterprising employee that they say, hey, you can have all this stuff if you want it. They take it home and it lands on eBay. So there's a lot of stuff that probably, people aren't expecting to be on eBay, maybe shouldn't be on eBay, but it ends up there. Outside of, you could say like the stolen items or something like this. Like I think most of this stuff is probably not stolen at all. It's just people just want the stuff to go away and they aren't thinking of where it could go. And they aren't thinking that someone else might be able to do something
Yeah.
with it. Like, hey, if somebody took this apart, perhaps there's secrets in it. Like there's a serial EEPROM in the meters. It has a bunch of data in there. It happens to there's 5 passwords, 5 different levels of security if you connect to the optical port on a meter. So if you hook up, there's open source software to
Yeah.
do it, but you need a 20 character password to access it. Those are all 5 plain text in the serial EEPROM in the meter. So if you can get a meter from wherever it is you want to do, you dump that, there's all the codes in there, you use those to access the thing on the front, right? So they're not thinking that. They might not know that data is even there. How many other things are there? Like I have one of these handheld meter
Yeah.
readers that people used to walk around. I just got this the other day. I'm working on making a video
Mhm.
for it. I haven't made it yet. It has a compact flash card in the back of it. It's just in it. It's never been wiped. It came from Chicago about 5 years ago, which I can tell you because there's a bunch of Chicago names and addresses of all the people that it was reading,
Oh
along
no.
with notes. What kind of great notes would you want to know as a meter reader? The gate code to access this house is this. Um, there's dogs in this backyard and they will
Oh
release them on you,
no.
right? Plain
Like now I want
text
to know
in the
what
file.
neighborhoods I'm
Yeah.
so curious.
I got I got 5 more that I bought on eBay this week that are showing up. So we'll see what those 5
Holy.
have, right?
Oh
I got
my
it. I got it.
God.
They're normally $2,000 brand new. I got it for $30 because it said it was not working. And all I had to do was take apart the battery, hook it up to my power supply, charge the cells back up, boots right up, Windows CE.
The
And yeah,
classiest of our tosses.
I'm telling you, and it works, and so there's nothing wrong with it. It
Yeah,
works
yeah.
great, right? Just somebody was disposing it. We don't need these anymore. Now we've switched to smart
Wow.
meters, and all the information's still on it. That's with everything you buy on eBay, right?
Here's a bonus question. What would you recommend to utilities companies who maybe are thinking about deprecating some of their older gear that they should do prior to handing it over to e-waste companies?
Yeah, I mean, you probably there needs to be. This is with anything electronic, anything that has a memory chip in it whatsoever. If it's you need to positively destroy that information. Like it has to be part of the supply chain life cycle that something that stores data gets destroyed. Like if I throw away a USB key, it's thrown away in powder form, right? Like it has been annihilated. Like it does not get, you don't just toss it in the trash can or whatever, because you know that even if you delete data, it wasn't really deleted. Who knows what other hidden sectors are there that store stuff and everything
Yeah.
else. So I think, it has to be part of the disposal. Can't just be like it goes away. And you have to really, I think, make an effort to understand what are these things, what pieces hold sensitive information. And just as they could have done everything the same, except for take out the compact flash card and dispose of that by smashing it with a hammer, and then say everything else goes to the e-waste company. This thing goes to a special company that is part of the signed agreement they must destroy all the data, or they're liable,
Yeah.
right? Financially liable, which is the only driver that causes
Yeah,
them to
I would agree with
destroy
you.
it.
Yeah, I'm kind of wondering if this should be part of the documentation for the product itself coming from the original manufacturer. Says when you're ready to dispose. Not that they probably would have this information like after 15 years, but it just seems like this is like, hey, when you dispose. I mean, when you look at your toothbrush, if you have an electric toothbrush, it tells you how to get the battery out. I don't think anyone does that, but you know what I'm saying, which is like, here's the way to, deprecate.
I'm looking forward to this video.
I'm so looking forward. I'm so frightened to find out, like, is it from my old neighborhood?
Oh, I think you're foreshadowing the future a bit, in that, possibly countries like, or, areas like the EU where they have, GDPR and these data privacy things. I mean, it could be that part of the requirements in the future are, what pieces in this, does this device store information? And if so, where and how does one dispose of that information? Like, as part of the, like you're saying, when you receive it, like, what, does this thing, store information, and how does someone properly dispose of this device without leaking information? That is not something like that anyone knows, like, or that is part of it when it comes out. Like, somebody has to kind of take it apart and figure it out, versus it just being a part of the process.
Yeah, in my mind, there's like an even simpler way of doing it. Well, simpler in quotes, right? But if the data on the flash memory, whatever,
Compact flash or
is
whatever.
encrypted,
Yeah.
you just need to destroy the key, and you don't actually have to destroy the physical device. But this is all implementation specific, and if they don't actually destroy the key, then it's the same. But there's many ways
and then
to
the
do
question
this.
too is, what's the sensitivity level of that data too? Because if it's sensitive enough, someone will figure out a way. Then you're counting on that the key would never be discovered via some other
somewhere
means.
else. Yeah,
obfuscation.
Yeah, and so if it's depending on how sensitive that data is, maybe it's just you got to hit it with a hammer, like it's hammer time, and then the thing goes in the trash can.
Just like, that kind of goes back to like what I was suggesting, which is, or what I was about to suggest, which is, maybe you as a company, like, you need to like trash all these USB drives or whatever. Maybe this is where you guys, declare it, what's the name of that movie, that Mike Judge movie, Office Space Day, where you just take it out, just like you did that printer. And you just like, look, guys, go wee wild. We know it's been really stressful. We'll get a shredder, and then we'll take everything out. But because at least that seems like where you can get everybody's mind around why it needs to be done, but also kind of make an event out of it.
Yeah, and I think it was Bunny that talked a lot about, just even devices like your keyboard and all these other things that everything has a microcontroller in it, has memory. It could be storing a number of keys that you're typing just as part of its own data logging process and everything else. So you don't realize, like, inside of a laptop or inside of your phone, how many, it's not just the hard drive, right, that knows information about what's been going on. And the same thing with that device he just what's it called? The precursor or something. I think it is that, it's a little, it was on maybe Crowd Supply.
Yeah, Crowd Supply. They're working on it right now.
Yeah, exactly. Where it is meant to be more of a trusted device for communication, and then it connects over an untrusted, Wi-Fi or something else. But that you can say, hey, I know how this thing works. I know if it's been tampered with it. I know where it stores information. Things that usually is completely abstracted away from the user, right? They have no idea where any of that stuff is.
Yeah. Okay.
But yeah, eBay's a great treasure trove of whatever you buy probably has the original data on it, because nobody's selling it on eBay. Is usually, if it's critical stuff like that, they're not the original owner and they don't care what's on it. They're making a buck.
Somebody else needed to do hardware. That. Yep.
They could have bought it from one of those, like, what do you call it? Storage units that you see a Storage Wars.
Oh, yeah,
they got a whole storage unit with, what are these power meters? Slap it on eBay, right? Who's this guy in Texas? He'll buy it. Just keep slapping them on eBay,
I would love that. Like, I've never seen the TV show Storage Wars, but I would love it if it was just like, you have a storage unit, you have an entire storage unit company somewhere in some really geeky place, and you just keep an open one after the other, and it's just all like classic vintage computers, power meters, old laptops. Like, oh my god.
I just have, if I won, I would just have to keep paying storage fees, because I want to keep all that stuff. I want to keep all that stuff. Like,
well, I was going to ask, like, how did it all kind of started with you buying one Nito Robotics vacuum cleaner, and you had to ask.
Life is funny like
so
that,
now,
right?
like, where are you keeping all this extra stuff? And is it a source of issues? Kind of the same way that people who are really into analog synthesizers and they have to figure out where to put it and still not get.
It's starting to get like, I have a rack in the garage and I'm storing stuff, and I have an attic, and it just it takes over everywhere you are.
Wow,
Yeah,
I don't have one of those because I live in the Bay Area.
It's kind of a gift and a curse. Yeah.
Well, Texas.
Yeah.
So probably
they have basements. Okay, last question, and this is for all the money. This is like the $1 million question. You're pretty resourceful. I mean, you know how to use eBay to find out the really interesting stuff, apparently. Just like any reverse engineer. If you were stranded on a post-apocalyptic island, what would you bring with you?
I heard this on the other show, and I was like, oh my God, like I've dabbled in like wanting to be like a survivalist, like, Bear Grylls or something. and then I quickly realized like, no, that's not me. And so I was like, I'd probably take it down to the most basic level, and it would have to be like water. Like what am I going to do to have like purified water? Because I was thinking like, maybe you bring a chainsaw or something, but it's going to run out of gas. And like, and so if you're like, as long as you can, or it was either water or fire. It was
like
one of
flint
those,
or
like,
something.
either I need fire. I need to be able to make fire because I'm going to freeze to death, or I'm going to die of, thirst because there's no clean water. And so it's, and so I'd probably bring something to make fire if I'm thinking about it, because I hate the cold. Like if I'm freezing, everything else is a problem. So as long as you make a fire, morale would be high. I could just burn my surroundings. I think I'd probably be pretty happy.
This also presumes that you would probably also, if you couldn't find food, you're just going to gnaw on wood. It sounds like the entire time.
I'm telling you, like I think as long as I can make fire, I could barbecue whatever it is I catch. Like I think I'd be happy.
Yeah, the water's hard to do.
Yeah.
The fire can be hard to do. Yeah, I hear you.
That whole twist in the stick thing. I encourage anyone who thinks that's how they're going to make a fire to go outside and do that right now, and you will quickly bring a flint with you to that desert island.
You probably fall over like blistered and crying.
Without a fire.
Yes, without a fire. You're better off with like a magnifying glass, or like maybe like
anything other than that twist in the stick method.
You got to do it like you have to have a long enough stick, and you got to. Oh my God. Yeah. They didn't make me do that in Girl Scouts, thank God. They made me be nice to people and sell cookies.
Those are both fantastic skills. If you're nice to people and you can sell something, you can go a long way in life.
It's not worked out well for me. I have not. Maybe I need to get in on this eBay thing. Hey, I got some clothes here. In case the audience doesn't know, I'm recording in my closet, so there's lots of clothes. So we've hit the end of the episode. Where can people find you, Hash?
So I'm on Twitter as at BitBangingBytes. I'm on TikTok as at BitBangBytes, because apparently banging is a bad word on TikTok. So no one could find me if they search for my name. So I'm now BitBangBytes on TikTok. And then if you go to the Recessim, which I'll just spell it RECESSIM.com, you'll kind of find links to these things. I have a YouTube channel with the same name with a bunch of smart meter videos, and then Discord, as you mentioned, if you just want to kind of chat with me about what's going on. I love chatting with anybody. And then there's the wiki. So primarily Twitter and TikTok and YouTube, I'd say.
Which
sweet. Yeah, we'll have links to everything,
yes,
of course.
with pronunciations.
There you go. Recessim.
Hey, audience, if you have comments or suggested names for the show, you can find us on Twitter, because that's truly the easiest way to find us, because we had a comment form. We'll link to the comment form, but we probably will never see it until years later, and maybe one of us will be dead by that point. Who knows? Start a pool now to figure out which one of us will be dead. You can find us on Twitter at unnamed_show. If you still can't find us, you can go to unnamedre.com.
I mean, you're listening to this, so hopefully you can find
You can still find us.
You have found them.
If you've made it this far and don't know who we are.
Well, maybe they're new, Anyway, You can find me, Jen, on Twitter at RebelBotJen, no underscores. And Alvaro, where can people find you if they...
I'm at Alvaro Prieto on Twitter and alvarop.com. Thanks to all of our patrons. Thank you so much. We're trying to record as much as we can, but schedules. So we're just gonna make up for it with awesome guests.
Really long episodes.
We got great feedback.
Well, I really enjoyed chatting with you, and I enjoyed listening to the other ones you had, and I think you're doing a great job.
Thank you. No, thank you so much. This was really, really fun. We as last time, we went in directions we didn't expect, but in a great way. As I'm very, very happy. So I hope folks enjoy it as well.
I'm happy too. Just want to make sure that I don't come across as not also happy.
I can see the face. Jen is not
I can confirm I can see both of these happy people.
Yes, everybody's happy.
Everyone's happy. There's no filters on. Nothing.
No happy filters. It's really unfiltered happiness.
We'll put those on.
Anyway, thank you so much for joining us, Ash.
Thank you.
Okay, have a good one.